Hi everyone. Today we have a few forces and two dimensions for AP Physics 1. The AP is coming up soon, so let's get started. We have a 5 kilogram block that is sliding across a horizontal surface. Here's our 5 kilogram block on a horizontal surface with a coefficient of friction between the block and the surface of 0.2. Two external forces act on the block, both directed forward along the direction of motion. Force A has a magnitude of 20 newtons and is applied at an angle of 40 degrees above the horizontal. So force A, with a magnitude of 20 newtons, is directed 40 degrees above the horizontal. And we have force B, which has a magnitude of 15 newtons and is applied at an angle of 25 degrees below the horizontal. We're asked to calculate the normal force acting on the block and to determine the acceleration. Let's start off by drawing our FBD. We have mg acting on the block downwards, Fn. We have our two forces, Fa and Fb, and we also have some force of friction opposing the motion. Now, if we're asked to find the normal force acting on the block, we're concerned with the forces acting in the y direction, up and down. So we'll write our sum of the forces in the y direction, which is equal to Fn if we're making the positive direction upwards. We'll also call the direction to the right positive. We have Fn plus some sort of Fa in the y direction minus mg and minus Fb in the y direction. And since the block is not moving up and down and is staying in place in terms of the y direction, we're setting this equal to 0. So to find Fn, we'll subtract or add some of the forces to the other side. So we'll subtract Fay over, add mg, and add Fby. Now, to find Fa in the y direction, we'll do our 20 newtons for the magnitude times sine of 40 degrees. When we have 40 degrees above the x-axis, we're going to use sine to find our y component of the magnitude in the y direction. We add our mg, which is simply 5 times 10 meters per second squared. And for Fby, we'll add the magnitude, which is 15, times sine of 25. Adding this all together, we get 43.48 newtons for Fn. Now, let's find the acceleration of the block. Some sort of acceleration in the x direction. If we're concerned with the x direction motion, we're going to consider the forces in the x-axis. So we have the sum of the forces, f of x, is equal to sum Fax plus sum force B in the x direction minus the force of friction, which is opposing the direction of motion, equal to ma. Now, like we did in part A for finding the y component of force A with sine, we're going to use cosine in the x direction. So we multiply our magnitude of Fa, which is 20, times cosine of 40. Same thing for Fbx. We have our magnitude 15 times cosine 25. Our force of friction is simply Fn times the coefficient of friction, which is also 43.48 times 0.2. So Fn times mu. And and we said this was equal to the mass of the block, which is 5, times some acceleration. Let's simplify this and get 5a is equal to 20. Divide over 5, and we get a is equal to 4 meters per second squared. For our second problem, we have a 4 kilogram boat that is being pulled by 2 ropes in still water as viewed from above. The boat is moving directly east. So we have our boat that is 4 kilograms moving directly eastward. Rope A pulls the boat with a force of 20 newtons at an angle of 20 degrees north of east. So we have rope A with a force of 20 newtons at an angle of 20 degrees north of east. To keep the boat moving straight to the east, a second force from rope B is applied at an angle of 40 degrees south of east. So we have some force B at an angle of 40 degrees south of east. We're asked to find the magnitude that rope B must have in order to keep the boat from turning, and we're also asked for the acceleration of the boat. Okay, if we're asked to find the magnitude that rope B must have in order to keep the boat from turning, we're going to consider the forces in the north and south direction. We can treat the north and south direction like the y-axis, and the west to east direction like the x-axis. And we'll define our positive directions as to the north and to the east. So let's start out by drawing our sum of the forces in the north and south directions. We'll set this equal to some force A in the y direction, or north and south, minus some force B in the y direction, and we'll set it equal to 0, since if there's no acceleration in the north-south direction, the boat will not be turning. So, we'll multiply the magnitude of force A by sine 20, which will give us its y component, and subtract the magnitude of force B, which we don't know yet. We'll just say F times sine 40, which gives us its y component, and set that equal to 0. If we add F sine 40 to the other side, we'll get 20 sine 20. And finally, when we divide 20 sine 20 by sine 40, we get our magnitude of 10.64 newtons. Now let's find the boat's acceleration. Since the acceleration is in the east direction, we're concerned with the forces in the west to east axis or the x-axis. So let's write our sum of the forces in the x direction. We have some force A in the x direction and some force B in the x direction. And we're adding them together because the forces are both going in the direction of the motion. And we set it equal to ma. We'll multiply the magnitude of force A times cosine of 20, since that gives us its x component. And we'll multiply the magnitude of force B times cos 40. The mass of the boat is 4 kilograms times some acceleration. Simplifying this, we get the acceleration is equal to 6.74 meters per second squared. Perfect. For our final problem, we have a 1 kilogram object that sits at the origin of a coordinate grid and is subjected to 3 force vectors acting on the plane. Let's draw our coordinate grid. We have the y and x axes and our 1 kilogram object at the origin. Force F1 has a magnitude of 20 newtons and acts at an angle of 20 degrees to the right of the positive y-axis. So F1, magnitude 20 newtons, acts 20 degrees to the right of the y-axis. We have a second force F2 with a magnitude of 15 newtons that acts at an angle of 45 degrees below the x-axis. And finally, a force F3 that has a magnitude of 30 newtons and points directly to the left in the negative x direction. Assuming that there is no gravity, friction, or resistance, we need to find the acceleration and direction of the object. To find the total force acting on the object, we're going to separate it into x and y components. We'll start by finding the sum of the forces in the x direction. We'll make the positive direction the positive y and positive x direction. So we have the sum of the forces in the x direction is equal to F1x plus F2x minus F3x, and we'll set it equal to ma. F1x is its magnitude 20 times cosine of 70. If we draw out the complement angle, we can see that 90 minus 20 is 70 degrees above the x-axis. We'll add it to the magnitude of F2, which is 15 newtons, times cosine of 45, and finally we'll subtract 30 since F3 acts directly left, and we'll set this equal to the mass, which is 1 kilogram, times A. Simplifying this, we get AX is equal to negative 12.55 meters per second squared. Let's do this for the y direction. The sum of the forces in the y direction equals F1y minus F2y, which is equal to ma. F1y, which is its magnitude 20 newtons, times sine of 70, which will give us its y component, minus F2y, which is 15 times sine of 45, equals the mass 1 times the acceleration. And simplifying this, we get AY is equal to 8.19 meters per second squared. Now, to get the total acceleration, we simply use Pythagorean's theorem, ax squared plus ay squared, and the square root of the sum, and we get negative 12.55 squared plus 8.19 squared, which is equal to 14.98 meters per second squared. Now before we find the direction, let's visualize what this acceleration vector looks like. We have some ax to the left, which has a magnitude 12.55 meters per second squared. And we also have acceleration in the y direction, which is 8.19 meters per second squared. The total acceleration vector looks like this, the sum of the x and y accelerations. This is the hypotenuse of a triangle we just made out of the different acceleration vectors. So the hypotenuse is A total. To find the direction, we can call this angle theta and use one of our trig identities and solve for theta. Let's do that now. Tan theta is equal to the opposite over adjacent side. Taking the inverse tan of both sides, we get theta is equal to inverse tan, opposite over adjacent. Theta is equal to inverse tan 8.19 over 12.55. And this is equal to 33.13 degrees. So our final answer for the direction is 33.13 degrees north of west. Finally, question B asks us how far the object is from the origin after 5 seconds. For this last problem, we can use simple kinematics. We have our distance equation, d, which is equal to v naught t plus 1/2 at squared. We can cancel out v naught t because in this problem, we can assume no initial velocity. So we set d equal to 1/2 a, which is 14.98 meters per second squared, times t, which is 5, since we want to know how far it is after 5 seconds. And this is all equal to 187.25 meters. I hope this video helped. Thank you for watching.